Hi, welcome to Apache Pulsar Development 101 with Python. I'm Timothy Spann, a developer advocate at StreamNative, and this is my talk today for Pulsar Summit Asia 2022. My background is in Flink, Pulsar, NiFi, which I call the flippin' stack, and other streaming systems and data. I've been doing this for over 15 years. I've done Spark, NiFi, Big Data Cloud, different ML, IoT, Python, Java. Worked at a bunch of different companies, Cloudera, Hortonworks, Pivotal, Ernst & Young, HPE. Now I'm here to show you what you can do with Python. We've got a QR code, get you right into some more information if you need it. You don't have to wait until we share those slides. Every week I put out a newsletter on LinkedIn. It has a lot of cool stuff. It has videos. It has podcasts, has links to code, tools out there, different articles, events coming up, pretty much everything interesting in the world of streaming and open source. So definitely check it out. In the world of Pulsar, there's a lot going on. And certainly Python is important, but remember there's a lot of things you could get done, perhaps without having to write any code. So first investigate that before you start writing all that code. Plenty of things you're going to need code for, some things you won't. Spark, I could do a SQL. Flink, I could do a SQL. CDC, I could do that with some YAML. Same with sending data to Delta Lake or Scylla or S3 or Elastic. ClickHouse, all those have sources and sinks that you can configure with some basic YAML, make it really easy to get code in and out. Apache NiFi, if you saw my other talk, shows you how easy it is to get data into and out of Pulsar with that. So check those out first, but let's get into it. I call these flippy apps because it sounds cool. And often Python lives at a couple different spots in a streaming pipeline. First off, Python is almost always available in these edge devices, whether it's a Jetson Nano, a Jetson Xavier, a Raspberry Pi, even going down to some of these smaller ones with the assistance of Circuit Python. You could probably run your Python scripts at the edge there. If not, you can run them nearby and maybe a gateway, slightly more powerful box next to it. Get your data into Pulsar, which could be sitting on one of those nanos or maybe on a little bigger gateway box. Get that data right into your main cloud cluster. And you don't have to do just the Pulsar protocol to get data in. You could also use Kafka, MQTT, WebSockets, AMQP. We'll show you a couple examples of those today. Once you get into your cloud, very easy to write your apps and have them work with Pulsar, Flink, and wherever you want to store your data once it's past its streaming time, or store it in your stream storage. Python can write apps easily to get data into and out of this cloud infrastructure, and I'll show you the security requirements there. We could write our Pulsar functions in Python, which is a great use for Python. We could write Spark apps in Python. We could call the data through Trino Presto SQL with Python. Another way to get your data out of Pulsar using the power of Python. And we could just have data sync into another data store, access it with Python there. So Python can live all different parts of your infrastructure, not just in your data science, but in your streaming, in your ingest, in your batch, in your SQL, wherever you need it to be. Now I have a antenna that's pointed to the clouds trying to get plane data. That is running on a Raspberry Pi 4, and I have a Python application that is reading data off of that device, formatting it, and making a call to Python, where we could do some more analytics. Very easy to do. We've got a link to that here at the bottom. Now, a common place to run your Python, as well as Java, is Pulsar functions. These are immensely powerful and pretty easy to use. Now, what's nice here is you define a couple of topics you want pointing to this function, and that can be changed at any time through the command line interface, very easy. And your function will get called every time an event hits those topics. You'll get activated in your run, and you could set up a log topic. So anything you need to log out there can go to a topic. So you don't have to worry about filling up that disk drive. And then somebody else, including another function, could parse those logs, so you could dog food the whole system there. And then coming out of Pulsar function, you could predefine an output topic and send a message to it, or you could decide that on the fly. You can even create topics on the fly. It's pretty great. Since this is just a regular app that you're deploying, you can use any number of pip libraries there. So as you can imagine, machine learning, data processing, calling databases, calling REST endpoints, whatever you need to do, you can do it, which is pretty awesome. Great way to get your logic embedded in a real-time system without having to worry about how do I consume messages, how do I publish them. That's all handled for you. Plus you get a whole context there to do some other things like get the ID, get access to logging. Ton of powerful things without much to do other than basic Python 3 coding. Now, once you've decided you want to build a function, fortunately, there's a powerful DevOps interface to do that. You've got a couple options there, including REST, but the easiest in my mind is use the Pulsar admin command line interface. As you can see in blue, that's the syntax for it. And that'll give you access to a whole lot of different commands. Now you can take a look at the status, look at detailed stats, trigger to execute it, list all the functions that have been deployed, get one specific one, run one locally. This is a great way to test before it's fully deployed. Create a new one so it gets deployed, whether that's inside a broker or out into something like function mesh for Kubernetes. You could also do updates to it. You could also delete it when you're done. A common one for me is when I want to redeploy it, put a new version out, I'll stop it, delete it, then I will start it, take a look at the status, look at the stats, list it out, make sure everything looks good, you're good to go. All pretty easy, all from this simple command line interface. Now, what does one look like in Python? It's pretty basic Python. You do have to follow this specific setup. So we make sure we import function from Pulsar. So you got to have the Python library for Pulsar out there. That's something you, as a Python person, you're definitely going to want. You set up your class, give it a name that makes sense for what kind of function you have. Put in that init, which you don't have to do anything. And then process is the one that's going to be called for each event. And that's going to be your input field there. And the context, this is the context where I can get all those valuable things that I want. Here you can see the logger. You can see that's how I get a message ID. Very simple. And that return, that's getting returned to that output topic. So pretty easy here. If you look at it, what part of this tells you it's Pulsar, just that one import line. The rest is pretty straightforward. You could put any kind of code in there, call other libraries, do what you need to do. Very simple way to write functions that extend the power of Pulsar with the language that you like. So I'm going to show you some examples in Python 3, and then I'll go out to the to my own computer and we'll go through a couple examples. We'll run them. We'll take a look at them. We'll go through there, do some demos. But I think we'll do the slides first, and then we'll go into the demo just to make sure we have time for everything. I think we'll have plenty of time here. So the first thing you have to do is, I'm assuming you have a Pulsar cluster running. If you don't, come back to this, save this video, come back into it, get something running. It can be Docker, it can run localhost. It is pretty small. Or you could sign up for, say, StreamNative Cloud or any of the cloud space, or install your own in a single instance in, wherever you're dealing with, like DigitalOcean, whatever you have there. Get it running. Are you running? Hopefully. Depending on your security, you should be good to go. Make sure you have the admin command line interface set up. We showed that with the functions. That admin tool does a lot of stuff. There are some other options there, and I know that there's work on another interface going on, but this is pretty simple to use. We'll go into Pulsar admin, and each area has its own command here. So you see tenants. These are commands that deal with tenants. Now in Pulsar, we're multi-tenant. So it's important that you have one. You might want to create one for every group you're working with, or even an application. Depends on how many things are going to be under that. So we create a tenant for conference. And then underneath that, we're going to create a namespace under this new tenant. And as you see here, that one makes sense for what we're doing today. And then we take a look, make sure that it showed up, and we'll see that. We take a look at namespace, make sure it shows up. But you'll see the common way this admin interface works. It's very logical, which section of the system are you working with? Some kind of command, and if it needs parameters, they'll show up after it. So now that we've got a tenant and a namespace, next level down is a topic. Now we can create a partition one or non-partition, which means it just has one partition that's named 0, but we don't have to go into that. So we'll create a topic. Now we see we have the word persistent. That is not required. We could have non-persistent topics. I don't see a lot of people using them. So just put that word in there if you're not sure. 99% of the time or more, it's persistent. Then we put our tenant in there, our namespace, and the name of our topic. We take a look at that tenant namespace. We'll see that topic there. You want to create a couple of topics. Again, if you don't want to create them beforehand, that's perfectly acceptable. As long as you have the settings set up, which they are in default. If the topic doesn't exist, we're just going to create it for you, which is really nice. Send messages there. If it's not there, I'll build it. Now, if you're someone who gets a lot of typos, maybe that's not the settings you want. You have a lot of similar name topics. But just a word of warning there. As we mentioned, for functions, you've got to have the Pulsar client installed. Now, depending on your architecture and what version you're using, you may have to install the C++ client. You may have to do a build. There is a library available for most systems already, and those are pre-built. So you probably don't need it, especially as of 2.10.1 or 2.10.2. Most of the architectures are out there, ARM and Mac and the M1 and lots of different ones. So it's probably okay. If not, I've got some pointers in my library there. I had to build it for the Raspberry Pi in the past. That's no longer the case. It installs really fast. Makes a nice way to send messages for your own little example devices here. I know they're a little harder to get now. Or other devices, maybe if it's a specialized hardware, you might have to build your own libraries. Check out the client libraries for Python. Hopefully all you got to do is a pip. This is a good time to install any other pips you might need. There's a lot of different libraries out there when you're in the world of Python. So it couldn't be easier to send a message if you wanted. We've got a single import. This is basic case, right? We're showing you the simplest case for producing messages. This is no login, no encryption, no security, no schema, nothing fancy. Not doing async calls, not doing error checks, not sending any kind of advanced message, no keys. Port Pulsar, create a client. Obviously, you have to point it to where you actually have a cluster, and that cluster has to be available on the network. It's not blocked by a VPN or a firewall. You get the idea. Once you've done that, start getting some messages. We'll run one. Create a producer from this client you just built. Point it to that persistent tenant namespace topic of your choosing. Create a string, encode it with UTF-8, send away, close to client, we're done. That is not something you're probably running in production, but great way to test your Python client, that your cluster's running, and that you could send a message, and then you could go look at the message, whether you use the command line interface to look at it, or another Python application. Now, most people are going to have security, and security isn't really that hard. In here, I recommend when you're running your app that you pass along the security settings to it so they're not hard-coded. Maybe you have that in a configuration system or in a file. A lot of options there, but let's go through it. So we're going to use the Pulsar client again. We're going to use the OAuth authentication, which is used by StreamNative and a lot of other providers. So I'm going to pass in the security settings. Now, the first one you'll see is, as opposed to what we saw in the unsecured one, it's not Pulsar : it is Pulsar plus SSL. So we're doing secure sending of messages up to the cloud. And you can see a different port from, instead of 6650, it's 6651. Again, you could change those. Probably not a bad idea. Again, you see that persistent tenant namespace topic, and we're passing in our issuer URL, a private key, and the audience that tells us, what my cluster name is. Pass those in, and we can make that authentication connection. There's an example program down the bottom, so you can see how to do that. It is pretty straightforward, but just make sure you get your key. If you're using StreamNative Cloud, they have a area where you could easily download this. Very easy to set this up, and you could see some examples in the in your cloud. Again, you can get a free version of StreamNative Cloud if you don't want to set up your own cluster. If you just want to play with security, it's a good idea out there. Now, the next thing that's common in production use cases is a schema. So as opposed to just importing Pulsar, I'm going to import a schema. Specifically, today we're going to do Avro. To do a schema in Python, we set up a class, that's a record, and we put the names of the fields we want with their type. Pretty straightforward. We could also put in null, not nullable. I've got links to some of those. Create our client again, but this time we'll create our schema. So when I create my producer from the client, I'm going to specify that schema, again, the Avro one. Also, I recommend setting some properties, the minimal one being the name of the producer. Again, if you're trying to trace what's going down, either Pulsar Manager or through command line or through REST endpoints, good to know who sent this message. Very helpful. So I create an instance of my record, set all the values, and then send it. Here I'm setting a key. This is very important for a lot of use cases, deduplication, identifying the particular message. It's used in a lot of different things. Unless you've got a reason not to, put a key on there, put a schema on there. Let's keep this data as high quality as we can. Important first step in data quality. Down the bottom is a link to an example application where I use schemas. You can see a full application and run it yourself. As you might imagine, JSON schemas are also supported. It is almost identical to the other one. The only difference being I create my schema against that record using the word JSON schema. Otherwise, everything else is the same. Example down the bottom for weather. Now, we've produced data. That's great. Someone's got to get it out. Now, we could use a sync. We could use NiFi, Spark, Flink, Presto, 1,000 different tools. But let's use Python. This is going to be a common use of Pulsar with Python, especially if you've got different workers in different servers or different clouds communicating to each other using Pulsar as your message bus. Easy way to do that. Import Pulsar, create our client. Now for the consumer, we're going to subscribe to that topic. I'm going to give it a subscription name. Now you may or may not pick a subscription type. If you don't pick one, one will be picked for you, and that is shared, which may or may not be what you want. So make sure you pick the subscription type that makes sense for your type of application, for this particular subscription name, and that you don't have someone else using the same subscription name on the same topic and using a different style. You could have a problem. Again, shared, no problems, except you may not get all the messages you expect because someone else could be using that subscription name and also shared and be sharing that workload, which is if you're doing a work queue, perfect. If you want to get all the messages in order, it's not what you want. You're not going to be happy. Choose exclusive or chew key shared. Take a look at the types. There's a couple of talks on that. Now here, consuming is a little different from producing. Producing, I could just fire a message and go away. That might be great for your use case. Or like for me, I will have on various devices like this one, this running continuously in some manner in a loop, constantly producing messages. Most likely with your consumer, you're going to be getting a lot of messages. So you're going to have to figure out, am I going to run forever? We're going to run a certain timed period. Things you got to think about. There's a lot of options in consumers, especially if you're using the Java version, a little less than Python, but still a lot of options. This is the most basic one. This is an infinite loop. That may not be what you want because you're going to have to manually kill it or have something kill this process because it's going to run until your Python runs out of memory or something happens. Maybe you want a counter, maybe you got a timer. Well, in this case, we're going to have an infinite loop on true. We're going to try to receive a message. If we get it, we print it out and we acknowledge it. This is important in Pulsar versus in other systems. We acknowledge that message so that this subscription gets that acknowledgement so it knows you read it. And why this is important is if, for example, I leave this running for the rest of time and I never send another message to it, those messages are just going to sit there forever, which may not be what you want, wasting space. Once I acknowledge them, if no more go into that, it's possible that I could get rid of that topic if I needed to. Something to think about. If a subscription exists and every message isn't acknowledged, if you're not out of space and you don't have anything set up specifically, it's going to live there. You might not want that. The very awesome thing with Pulsar is do not have to use the Pulsar library to talk to it. Now, if you've installed MOP, which I call MOP, which is MQTT on Pulsar, it's a very easy library to add to the server. Set some parameters, drop an R file somewhere, start it up, and now I can get MQTT messages. I can also send them via this protocol. And this is really nice if you're doing these end devices because they probably use that anyway. This makes it very easy for you to move existing apps that are using Python over to using Pulsar without having to do anything special. So we could just install the Paho MQTT library, import it, create a client, get our data the same way as before, but we connect. A typical port is 1883, and we can use that same one in Pulsar. Pretty awesome. And then we publish to it. We send the payload, quality of service, and if we want to retain it. Now, the thing that is different is MQTT doesn't usually have the same type of topic naming as Pulsar. So if you want to just put in a regular name or one that made sense in MQTT, you can, but it's going to default to your default tenant namespace, which may or may not be okay for you. It is better to explicitly put it in there if you can. If it's something hard-coded, then there's ways to work around it. I have an example of a talk I did on MQTT with Pulsar. Give you some more details there. Pretty straightforward to do this. It's not a bad option, especially if you already have that running somewhere. Another very interesting one, which is a lightweight library out there, typically done from a web page, but can also be done with Python. Thank you, Python. Install this library. Import a couple of things. There's a little extra steps here because this is going over a web protocol. So we're including that base 64. So I connect to that server that we had over our REST point, same one we use for admin. And then I say I'm a producer, and there's that persistent again. Tenant, namespace, topic, create my connection, get my message, encode the message in bytes in ASCII. Once that's done, I've got a base 64 encode it. And then I've got to decode it as ASCII and then put it in this very specific format. See, this JSON dump here will format this as proper JSON. With that, payload has to be base 64 encoded. The rest doesn't. And you want to set a couple of properties so you know what you're doing. And maybe there's some a context. Then you get your response back and you know it's succeeded. I've got links to examples and the documentation out there. Interesting way to do this. Again, if that's the only library you have, or that's the only protocol that can get through your network, not a bad way to send data. I do this more often in JavaScript from an HTML page, but this works perfectly fine in Python, and this is a way around installing other libraries or opening up ports in your firewall. This is a very compliant port 8080 WebSocket call. Nothing weird here. Can also use the Apache Kafka library. Install that one. We import the Kafka producer. Pretty easy. Point it to Pulsar. Again, we have to have COP running, which is Kafka on Pulsar. Make sure you got the right ports there. Everything's open. Kafka is a little trickier than other ones. I've got some links to COP there. Send the data over. Flush it when you're done. Pretty easy way to get your data to Pulsar. Now, we also can do functions in Python. You saw a little bit of that text. So here we're using a lot of Python. So I've got Python running on my edge device over here. It sends a message to the Pulsar topic over the Pulsar protocol, but could be Kafka, MQTT, AMQP, WebSockets, whole bunch of other options. Gets that into a topic. My function consumes it, enriches it, puts it into another topic, and then I can have a Python app running in a Jupyter notebook, consuming that, using that for some ML example. And I have an example out there that I use for chats, and I add some sentiment analysis in there. Really easy to do with Python. Again, how do we do that with the chat? Pretty easy. We showed you the basics of this. If we want to deploy a Python function for Pulsar, this is the syntax. It is pretty straightforward, but this is the syntax. I've got it documented at that GitHub. We create it. I recommend AutoAct. We point to where the Python exists. Must be available from your cluster. This is something people using Hadoop will remember. Got to load it from somewhere. If you have a shared file system, that might be a good place to put it. Again, there's some options there with function mesh and other things, but somewhere it's got to be able to see it. We point to the class name. You saw that when we defined it. Inputs, if you have them, are the list of topics that are coming into this function. Log topic, if you want it, is where any logs you write to are going to go. Give it a name. Make sure it makes sense, because you might have a lot of them. If you want output defined, define it. Anything in a return will go there. Again, you could redirect to your own topics if you need to. but that's a default. I have a links to a lot of examples, especially for edge devices. These are the perfect fit for Python. Python runs pretty quick on them, doesn't take too many resources, ton of libraries, and most of these third-party sensors have Python libraries for them, so it makes it really easy. I also have a Python library for creating test data, which if you're starting out, you may not have data. So it'd be nice if you could create some really easily. And that's what I have here. So if we take a look at this example, it's pretty straightforward. A couple of things here, but these are the important ones for Pulsar and the Python Faker library. Here I'm setting that up. I create a class so I could use it for a schema. You can see here names and types. And here I connect to Python. I make sure I put all my producer stuff there, and there's the JSON schema. Pretty straightforward. And here I'm just going to go through a loop and create all these fake records and send them to Pulsar with a key. Pretty straightforward, but something you might want to think about. I'm going to show you this if you want to connect, and then I'll go into the demo and show you some different libraries I have out there. Definitely check out my GitHub. I have a ton of examples there, adding them every couple of weeks. Also, I have a page here for Python. You can get access to a bunch of other stuff we have out there, and some source code and some recordings we have. So definitely check that out. And let's take a look at the demo. Now, I've got a couple different examples here. If you want to follow along with these, you can download these right away. This demo here is pretty well documented, so I'd like to point to this one. It links to a lot of other source code and examples and follows through different steps and different types of data, like sensor data. This one here is a built-in little app that just sends to MQTT. Very easy for us to do that. I got some examples here on how to use sensors, Python and Pulsar, Twitter, planes, electricity, so many different things we could do. Once we get that data in, we could join it with Flink SQL, do different kinds of group bys and queries on it. So check that out. Now, you can also get the Python library working on the Jetson Nano. And once you have that installed, very easy to set up your record and start sending data from a Nano, just like anything else. Depending on how many records you want to send, you have loops, lots of fun stuff there. This is an example of the same idea on a Raspberry Pi. And here, this one is the one that's calling that plain data. Plain data is made available from a local endpoint that produces JSON. So part of the functionality here is gets the data, cleans it up, and makes it available from a local REST endpoint on the device. That's also the same one we see if we go to the local website on that server. This is what feeds this map here, but we could use that ourselves, clean that up, and send that to Pulsar real easy. Let's go into some demos here. Now, first up, let's do a sending over WebSockets. So you can see here I have a WebSocket program here. It is pretty straightforward. Import that like you saw there. That's the name of my server. That's my laptop. This is a device next to my laptop. So we could just, let's run Python. I think it's 3.9 on this one. Let's see, we're able to send a message. Told me that it's sent okay. We also have one that'll read it. So let's look at the reader. And as you see here, pretty straightforward, but we have a loop. We're just going to wait forever. That same server, same topic. So we can do that, right? Let's test the reader. And let's send ourselves a message. We sent 1, 2, 3. 4, 5 messages. How many we got over here? 1, 2, 3, 4, 5. And it shows up right away. This is a great way to communicate, say, from your devices to your server or wherever your data might be. Pulsar is a great message hub to connect different systems and have more than one person using the same stuff there, which is great. We have a lot of stuff. We can also test MQTT. Let's take a look at that. Pretty straightforward. Again, pointing to that same laptop of mine here. And we're just going to run this one and send it pretty fast. Nothing too complex here. What else can we do? Remember I said passing in those parameters. So if I want to run one locally, I could see how I do that. There's my Python. Here I'm sending in that topic name. Here's the server name and the port. So we could look at that particular Python app. I've got a lot of libraries here. That tends to happen in Python. Some of them are for sensors, some are for formatting, some are for getting some parameters. I like to add a lot of stuff. Here I created my topic. As you see here, these are all required. This is a hint for the current version of the Lake House for Delta Lake. You have to have every field that can't be null. That's probably changed as of now, but that's why I had them all not nullable. We get those parameters in. If we have authentication, we use it. If not, we don't. I create a producer, use a JSON schema on it, give it a producer name and ID, start up my sensors, get some temperature data, get some disk space, get some readings from the sensors, and I format that in the record and send them via Pulsar, put in that key. And I have that going in a loop and it just runs. And we could run that there. We saw that. Let's run that. Laptop sensor run. You can see it created the connection. See it pulled it from the pool, got that producer, pointed to the topic, and as you see, it automatically added that partition 0, because everything has one partition and 210. And you can see we're getting the output of what we're sending there. And it's just sending a steady stream of messages every 5 seconds. Pretty easy to do. Now we have that other application we peeked at before, and we can run that one, this ADSB run laptop. Let's get that running. And this is not outputting too much, and I'll show you why. And we look at that, the cloud ADSB. Now what this is doing is same things we saw before, but this gets data in a little different place. It is grabbing that from that REST endpoint we saw before and just sending it. I put a sleep there for a second so I don't send too much data, because this is pulling down a list of multiple aircrafts. It's not just one. This could be a lot of records. So we don't want to do that. And we could take a look, curl, and you can see that's why I'm not sending this as individual, because there's a bunch of data here that's got to be parsed. And I do that in that Python function just to pull these apart later. But I want to grab this raw data, and we store this raw data, and then we store a cleaned up version of that data. Pretty easy to do those things. And you could check that out among all the different example apps I have out here. If you look at my GitHub, ton of options there. I hope you've enjoyed my talk. I don't think I've gone over. Thank you for coming to my session, and I'll talk to you again soon at the next conference. Hopefully, I'll see you in the real world on these. It's been great being here today.